Let's take a look at this problem. We've got tangent theta is equal to 8 over 3. And theta is between pi and 3 pi over 2. And we want to find sine 2 theta and sine theta over 2. Well, first off, let's examine what we're given. Okay, it's in quadrants from pi to 3 pi over 2. That'd be this quadrant where everything's negative. So tangent is going to equal to negative 8 over negative 3. Remember, tangent's y over x, so that's y and this is x. So I got r squared is equal to x squared plus y squared. So r squared is equal to negative 3 squared plus negative 8 squared. So r squared is equal to 9 plus 64. R squared is equal to 73. Double check that. Okay, yeah. So then r is equal to square root of 73. Now let's see what we're looking for. So the first one we want is sine of 2 theta. Sine 2 theta. So our double angle, sine 2 theta is equal to 2 sine cosine. So that's equal to 2 sine theta cosine theta. So we need sine theta. Sine theta is equal to y over r. And y is negative 8 over r, which is square root of 73. And if I simplify that, I multiply top and bottom by square root of 73. I get negative 8 square root of 73 over 73. Now cosine theta is going to equal to x over r. So we're going to have negative 3 over square root of 73. Multiply top and bottom by the square root of 73. We got negative 3 square root of 73 over 73. But on this particular one, I'm going to use the version where the square root is still on the bottom. So sine theta is equal to negative 8 over square root of 73. And cosine is equal to negative 3 over the square root of 73. We'll see why when we simplify this and make it a lot easier. Well, negative times negative is positive. 2 times 8 is 16, times 3 is 48. And down below, square root of 73 times square root of 73 gives us 73. So that would be our answer. If I had chose the simplified version, it would have been a lot harder to simplify. So when you're using sine times cosine and they both have a square root down below, then always use that version because square root of 73 times square root of 73 cancels each other. Now the other one we need is sine of theta over 2, which is this formula. Let's first talk about the plus or minus. Now they tell us that the angle's in this quadrant. So I want to choose something. This is 180 degrees. This is 270. And theta's here. And let's pick something for theta. Let's say it's 200 degrees. Now half of 200 degrees, 100 degrees, would be up here. So this will be where theta over 2 falls. I always choose a simple number example to help me wrap my mind around where it should be. Okay, so we're in this quadrant, which means sine is positive in that quadrant. So the version of that formula we want to keep is we want to keep the plus. And then it's square root of 1 minus cosine theta over 2. So we're going to plug in cosine. And the simplified version is a better one to plug in here. So I'm going to plug in this negative 3 square root of 73 over 73. All over 2. Well, negative negative becomes positive. So we got square root of 1 plus 3 square root of 73 over 73 all over 2. Now I don't want the fraction inside of fraction, so I'll multiply everything by the LCM of all their inner denominators. So I'll multiply everything by 73. 73 times 1 and 73 times 3 square root of 73 over 73. And 73 times 2. So that's going to give us square root of 73 plus, so 73's cancel. So we got 3 square root of 73 over 646. Now we can't have a fraction inside of a radical, so I'll split it up, put a square root on top, and put a square root on the bottom. But we can't have a square root down below, so we're going to multiply top and bottom by the square root of 146. Okay, so that's going to give us square root of 146 times 73 plus 3 square root of 73 over 146. Now it probably doesn't do us much good to actually multiply the 146 through there. The main things that we tried to get rid of, can't have a fraction square root, can't have a square root in the denominator, can have a fraction, fractions are taken care of at this point. So that'd be our answer.